Hello everyone. We are going to discuss discrete mathematics. Discrete mathematics is the study of discrete objects and relationship among them. We are going to start with set theory. Basically, a set is an unordered collection of distinct objects called as elements or members of the set. Basically, a set is an unordered collection of distinct elements. Generally, we represent sets by capital letters like capital A, capital B, X, and so on. And elements are represented by small letters. For example, we have the set capital A equals to 1, 2, 3. We represent set in curly braces. We can say that 1 is an element of capital A, but 5 is not the element of capital A. Two sets are equal if and only if they have the same members. If two sets are equal, if they have the same members, like A has the elements 1, 2, 3 and B has the elements 1, 3, 2. So they have the same members, so A equals to B. We can also represent set like this, like if we have the set capital A equals to A, E, I, O, U. We can also say that A is the set of X such that X is a letter in the English alphabet and X is a vowel. So we have some special symbols which represent some specific sets, like by capital N we represent the set of positive integers, by capital Z we represent the set of integers, by capital Q we represent the set of rational numbers, capital R represent the set of real numbers, and capital C represent the set of complex numbers. We also have a universal set we represented by capital U. For example, in plane geometry, the universal set consists of all the points in the plane. And for example, in the human population, world population can be represented by universal set capital U. We also have empty set or null set, which is represented by phi, which means that there is no element in the set, which is an empty set. We also have subsets, like according to the definition, if every element in set capital A is also an element of a set capital B, then A is called a subset of B. We represent it like this: A is a subset of B, or we can also write it like this. So for example, A has the element 1, 3 and B has the element 1, 2, 3, C has the element 1, 3, 2. So we can say that A is a subset of C, A is a subset of B. We can also say that A is a proper subset of C or proper subset of B. So proper subset can be represented like this. So B is not the proper subset of C because B and C are equal sets. We also have Venn diagrams. So Venn diagram is the pictorial representation of sets. So suppose we have the this is the area, rectangle area is the universal set capital U, and we have the another sets A and B. So here A is the subset of capital B. So you can say that A is a proper subset of capital B. So another sets A and B are disjoints because they does not have any common elements. They are separate sets, so they are disjoints. A and B are disjoints. So here A and B are not disjoint sets because they have some common elements. So this is the common area. This is the common area which have the common elements in A and B. So we also have set operations like A union B. So A union B definition tells that A union B is a set of X such that X is in A or X is in B. So either X belongs to A or either X belongs to B. So A and B have all the elements of A and B. Another definition is A intersection B. A intersection B is the set of X such that X is in A and X is in B. That means A and B is a set of the elements which are common, which are in A and which are in B. A complement is the set of X such that X is in universal set capital U and X is not in capital A. So all the elements after rejecting the elements of capital A is the complement of A. A minus B is the set of X such that X is in A and X is not in B. So after removing the elements of B from A, we get the A minus B. For example, A is the set have the elements 1, 2, 3, 4. B has these elements 3, 4, 5, 6, 7, and C has the elements 2, 3, 5, 7. And we have the universal set capital U equals to set of positive numbers. So U is the set of X such that X is in positive integer. So A union B would be all the elements in A and B. So what will be the A union B? So A union B would be 1, 2, 3, 4, 5, 6 and 7. Then A intersection B would be the common elements in the A and B. So here you can see that. So 3 and 4 are the common elements in A and B. So A union C would be all the elements in A and C. So 1, 2, A union C would be 1, 2, 3, 4, 5 and 7. A intersection C would be common elements in A and C would be 2 and 3. A complement would be all the elements except elements of A. So here would be 5, 6, 7 and so on. A minus B would be 1, 2. So we have also laws of algebra of sets, like we have idempotent law, that means A union A equals to A and A intersection A, it would be A. We have also associative law, like A union B union C would be A union B union C, and same for the intersection. Like commutative law, A union B would be B union A, or A intersection B would be B intersection A. That means order does not matter here, whether it is A union B or B union A, whether it is A intersection B or B intersection A, the value would be same. Distributive law, again that union is distributed over intersection and intersection can be distributed over union. So identity law, that means A union phi equals to A and A intersection phi would be phi. So there is not common between A and phi would be phi, and union of A and empty set would be set A, and union of A and universal set would be universal set, and intersection between a set capital A and universal set would be set capital A. We have also involution laws, like the complement of A would be set capital A, and we also have De Morgan's law, which follows by sets. So complement of A union B would be complement of A intersection B complement, and complement of A intersection B would be complement of A union B complement.